One of the most remarkable innovations in the history of technology has to be the introduction of the undo key. Everyone knows what Control Z or Command Z refer to, right? I mean, I don't know many people who have not used the undo function, whether they are doctors, engineers, graphic designers, students, teachers, even grandparents. I mean, many of us have lived in the pre undo era, but I don't know what life would look like without this undo function. Many books refer to this undo function as the inverse function. And on this video, we're going to talk about this very important function. If we have a set of numbers, let's say we have 1, 2, 3. Let's just start with the 3 natural numbers. And let's just say we have a rule, the function. The rule is that any input, this is the input, the set of all inputs or the domain. And let's just say the rule is such that any input, you're going to add 2 to it. Okay, so that's a very simple definition. So this becomes the set of all outputs here for that rule, that function. And that would mean that 1 under that rule, f, would go 1 plus 2. That's a rule, right? So that's going to 3. 2 in that same way would go to plus 2. That's 4. And 3 in the same way, obeying that rule, would go to 5. Now, we want to undo. We want to undo. We want to come back to what we started off with. We started off with 1. Okay, 1 became 3. The only way to undo and come back to what we had would mean that we want a function. Let's just call it I. I of 3 must be equal to 1. I of 4 must be equal to 2. And I of 5 must be equal to 3. Is that right? Just take a look at this. A new function that is actually taking me from 3 back to what we started off with. That would mean undo, right? A new function that's taking the value 4 back to what we started with 2. The new function that's taking 5 to the original value called 3. That would make this an undo function. And this undo operator is what we will call the inverse function. Inverse function of what we had, inverse of f. F was taking the input and adding 2 to it. So to bring back to the original, to undo what we have, basically the inverse function would just be taking back whatever we had, subtracting 2. Is that right? If you're adding 2 to go somewhere, from 3 to come to 1, subtract 2. From 4 to come to 2, subtract 2. From 5 to come to 3, subtract 2. So this is the definition of the inverse function of f. We have a fancy notation for f inverse. That's the fancy notation, but it actually means the same thing. Let's take another example. Suppose now we have numbers here 2, 4, and 10. All right, and we've got another set here. This is the domain, remember, the input. And this is the range. And let's say the numbers in the range we've got are 8, 64, and 1000. So that the rule that's going to connect 2 to 8, 4 to 64, and 10 to 1000 can be written as g of any input. It's actually cubing each input. 2 cube is 8, 4 cube is 64, 10 cube is 1000. And now if I want to undo this operation and bring back all these numbers back to what we started from, the original number, using the fancy notation, g inverse of 8 must be equal to 2, or I have g inverse of 64 must be equal to 4, or I have g inverse of 1000 must be equal to 10, then I am literally saying that this rule g inverse is, for any x, would be equal to the cube root of the input. G inverse of any x, g inverse of the input, would be the cube root of this number. Now, one interesting thing to note about this inverse function is this. The domain of the function g becomes the range of the inverse, because inverse is going from here, right? That's it's going that direction, it's going in this direction. So this becomes the range of the inverse, whereas the range of the function, the original g, will become the domain of the inverse. Let me write it properly, okay? The domain of g of x will be the range of g inverse of x, and the range of g of x will be the domain of g inverse of x. What does that mean when you actually interchange the domain and the range? We get the undo function, but what does that mean visually? Let's take a look at our calculator. I'm going to enter a list and spreadsheet page. The first column, I'm going to call it domain of f, and the second column, I'm going to call it the range of f. I'm just going to enter some random numbers here, 2, 3, 5, maybe 9. This is just for demonstration purposes. And here the range, I'm going to enter numbers like 4, maybe 0, and then 11, and perhaps 13. All right. So I've got some data points, both sets, input, output, domain, range. And let's just see what's going to happen if we were to make a scatter plot. So I'm going to add a graph page, and this time we are going to make a scatter plot of the data items that we have. The x values will be coming from the column that we labeled as domain of f, and the y values for the scatter plot is going to come from that column that we called range of f. And when I hit enter, that should give me something, although I'm not able to see everything, and that's because, you know, it's out of the range of this axis. So let's go and see what we can do. Windows zoom, let's say zoom data, and there we got all our points. All right. Now it doesn't make much sense to us. So what we do is, because they are random data, right? So let's try and see whether we can connect them. And if we connect them, what are we able to see? So those random disconnected data, when we connect them, that's the connection we see. Okay. Now let's see if we were to flip the x and the y. See what we saw earlier, that the inverse function, the undo function, happens when the input becomes the output and the output becomes the input, literally an interchange x and y values, right? So let's try and do that. So I'm going to go and make another scatter plot. This time, watch what I'm going to do. The x values are going to be the range of f, and the y values are going to be the domain of f. So what have I done? I've actually interchanged. The input of the original function becomes the output of the inverse function. All right. So here we go. And again, we can't see everything. So let's go and zoom to fit the data. Zoom data, and there we've got some, those are in red. If you can't see that, let me just go and change the not the color, maybe the attributes. Okay, and let's make it a square, or a, what should we make it? Okay, the cross is good, but we still want it connected. Okay, so that's the connection we have. Here we go. So the red graph, remember, is the graph obtained by interchanging the x and the y values from the original function, the original relationship. And because of that interchange, x becoming y, this literally looks like, you know, it's flipped. You know, that point out there becomes this point out here. This point out here becomes this point out here. This point out here becomes this point out here. And that point, which was the y-intercept, looks like the y-intercept there, becomes the x-intercept here. Now, because of the aspect ratio of this screen, we're not able to say, you know, the symmetry, x becoming y and the y becoming x. It's almost a reflection. Because even if I draw a graph of the function y is equal to x, okay, and let me change the color so that it will become better for us to see this. The color, let's make it, come on. The color, if I make it green, and if I make that like a dotted line so that we can see what's going on, there you go. That's the graph of y equals x. Now, when the x and y coordinates have interchanged, you can see this point has come here and this point has come here. You know, you can see that. But this line y equals x, we're not actually able to see it more clearly what the symmetry is because of the aspect ratio of this calculator screen. But fear not, I've got another option for you. This is GeoGebra, and I've entered the function x cubed. F of x is equal to x cubed. That was the example we saw earlier on. And here this dotted line is the line y equals x. If I just check show inverse, the undo relation, and I get that in green color, and maybe you can't tell much from this graph right now, if we just make some changes to the start value, and let's just see what we can see when we animate. And so when I move the slider along to see the two graphs, the green graph is the inverse relation of the cubic function, which is shown in that dark reddish brownish graph. You can see that it is a reflection. It's easier to see here because the aspect ratio on GeoGebra is better. Can you see that? It's actually a reflection about the line y equals x. And maybe to make it, to drive the point further, let's take a point on the graph. So I'm going to take a point on that graph of y equals x cubed. I'm going to try and reflect that point about the line y equals x. And the moment I do that, I can see that the reflection of that point, the x coordinate 1.5 becomes the y coordinate on this graph. The y coordinate here becomes the x coordinate here. And therefore, we can also see that they are actually reflections. That point is actually a reflection about that line. And if I try to move this point along the curve y equals x, and you can see that every corresponding point, now it looks much more clear that it is symmetric about that line y equals x. You can see the x coordinate 1.29 is the y coordinate here, and the y coordinate 2.14 is the x coordinate here. And these points, as they move along those inverse functions, as we were to call it, are actually mirror images about that line y equals x. So what did we see today? We saw two important things. One, the domain of the function becomes the range of its inverse, and the range of the function becomes the domain of its inverse. In other words, the input and the output get interchanged when you're talking about the function and its inverse. And the second thing we saw was that the graphs of the function and its inverse are symmetric about the line y is equal to x. In the videos that will follow, we will discuss the algebra, the graphs, and other aspects of inverse functions. But I want you to think about what I mentioned at the start of this video. What would life be like if we did not have this undo function, this inverse function in our technological world? And what would it be like if we did have an undo feature in our real world? Would we actually use that undo feature to take back words that we said we should not have said? Would we actually use the undo feature to undo things that we should not have done? Let me know your thoughts in the comments below. My name is John Paul Raj, and my mission in life is to make the learning of math fun.